MySQL, PostgreSQL, MariaDB are all examples of relational database systems. We call them relational because we can establish relationships between the tables inside the database. And we do that with joins. There's 4 different join queries that we want to talk about: the right, left, inner, and the full outer. And we're also going to talk about union, and we'll get to that towards the end. So to explain the different types of joins, I've set up a simple database, and inside the database are 3 tables with data you would expect from a school district. We have a table regarding the school buildings, and inside there are what you would expect to see in a table regarding school buildings. You have all the physical characteristics of a building, the address, what city it's in, the zip code, who the building administrator is. But the highlight that I want to show you from this table is over on the far right, the school ID. The school ID is a unique number. There's no duplicates. This is going to be the primary key of this table. This way we can refer to any row on the table by its school ID. And we don't have to worry about the possibility of duplicates if we use one of these other fields in the table. It's very possible a school might have the exact same first name. That would be a poor field to do a search on. So we're going to use the primary key. And the primary key is also what we're going to use on our relationships, which I'll show you shortly. Here's what our teachers table is going to look like. And again, like the school building table, it's the exact same layout. You have all the information you would expect to see regarding teachers, their home address, the city they live in, and just like in the school building table, each teacher is going to have a unique teacher ID. We could also use a social security number because those are unique numbers. But for our example today, we've just set up a unique number called teacher ID. And lastly, this is our courses table. These are all the courses that are taught in our make-believe school district. And it's set up the same too, with a little bit of difference that I want to show you. Over on the left is what you would expect in the table about courses. The course's name, the description of it. We can group our courses by classification, which would make sense if you want to see all your science courses. You would have a classification. Over on the right, though, we can see a collection of all the primary keys that we've talked about so far. So we have a school ID, and here are the school IDs from the school table that we saw, and same thing with the teachers. Plus, just like all the other tables, each course has its own ID. So, for example, if we look at the first row, we know that the botany class is taught in the school with a school ID of number 2, and it's taught by a teacher whose teacher ID is number 3. So these are what we're going to use to set up our relationships or our joins. And like we mentioned earlier, we're going to talk about 4 different joins: an inner, outer, left, and right. Left and right joins are almost identical and pretty much do the same thing. We're going to go over those first. Inner and outer joins are completely different, and you'll see that in a little bit too. So let's start off with a left join, and we're going to use our courses and our teachers table from our make-believe database. So as a reminder, here's what the tables look like. Here's our courses table, and down below is our teachers table. Probably the easiest summary of a left join is we're joining 2 tables together So if we look at our query, we're going to join the courses table with the teachers table. And because it's a left join, our results will have every record from the table on the left, or the courses table. And then it will also show us any records from the table on the right where there's a relationship, which would be the teachers table. So what we're going to have in our results will be all the records or all the courses being taught, and it will show us if there's a teacher assigned to them. So let's run our query and take a look at our results. So here's the first 3 records of our query, and since we're seeing every course that's available, whether or not there's a teacher, that's what we see here. The first 3 courses do not have a teacher assigned. So these fields from the teachers table are empty. If we look at the next 4 records, now we start seeing courses that do have a teacher assigned or teaching this class. So these next 2 records have teachers, Cal and Patricia. And then our civics class down below in record 6, there's no teacher assigned. And then here's 3 more classes. And let's take a note here that Granny Grammar teaches 2 classes. Granny Grammar teaches Earth Science and Earth Science 2. So, as expected, we had 9 records in our results because we have 9 courses. I don't know if you noticed, but there was one teacher we did not see, Sully Substitute. That's because Sully is a substitute teacher and isn't assigned to our class. So we would not expect to see Sully in our results. Let's take our example a little bit further, and let's pretend that our school administrator needs to hire teachers to fill the classes that don't have teachers right now. So we're going to do the same left join that we did before, but now at the end of it, we're going to add a where clause. We only want to see the results from the previous results where there is no teacher. So that's what the query looks like, and let's run it. And now we're only getting results where there's a course and no teacher. So there's 4 of them. Let's clean it up a little more, because after all, this is for the school administrator. So what the school administrator is interested in is the name of the course and what the course is about. So instead of using a wildcard like we did before, we're just going to specifically say we want the name from the courses table, and we want to see the description from the courses table. Everything else in the query is the same. And this is what our results look back. Now we get the same results as before, but now they're cleaned up for our school administrator. So the school administrator knows that they have to hire a teacher to teach botany. And this is what the course is about. Let's move on to right joins. And like before, we're going to use the same tables, the courses table and the teachers table. And here's what they look like as a reminder. And the quick summary of a right join is pretty much exactly the same that we talked about for a left join, with the difference being that we're going to join 2 courses, or 2 tables, the courses table and the teachers table. This time we're going to see all the records from the table on the right, or the teachers table. And then we'll see any records from the table on the left if there is a relationship between the 2. So let's run our right join query now. And the first 2 records that we got back, we see that there's a teacher teaching each class. Same thing for the next 2 records. In record 6, we now find a teacher that does not have a class they're teaching, which we would expect. It's Sully's substitute who's a substitute. And we also find Gary and Sally also um, are not assigned to a class right now. So our query produced 8 records. And as a reminder, Granny teaches 2 classes, Earth Science and Earth Science 2. So let's do the same query again, and this time we only want to see the classes that Granny teaches. And to do that, we're going to do our where clause like we've done before. And if we look at the query, it's exactly the same that we did before, but this time our where clause, we're only interested in the results where the teacher's name is like Granny. And here's the 2 classes that we saw before. Granny teaches Earth Science and Earth Science 2. Now we'll move on to inner join. I like inner joins, and I think they get used the most. Unlike a right or left join, where you're seeing the entire contents of one table, that's not how an inner join works. An inner join, we can join 2 tables, but we will only see the matches between the 2. So if you have 20 records in one table and 30 records in another table, but there's only a match between 3 records, that's all you're going to see in your inner join. So let's do our inner join, and we're going to join our courses table and our teachers table. And we're going to establish the relationship on the teacher ID. So let's run this query. And now we're only getting records or results if there is indeed a match between a teacher ID in the teachers table and the teacher ID in the courses table. So if we take a look at the results, we'll see that all of our results will have both courses and teachers. And if we add the primary key and do the same query again, this time we only want to see the name. We want to see the teacher ID, which is the primary key from the courses table, and the teacher ID from the teachers table, which is the primary key from there. We can see how we got our results. Because for calculus, the teacher ID in one table had the same teacher ID in another table. And that's how we got the results for our inner join. A full outer join is kind of unique because with a full outer join, we're going to see the results of all the matches or all the relationships where there's a match. We're also going to see all the relationships where there is not a match because they're all treated differently. But they're all put together in our full outer join. So like before, we're going to use our teachers and our courses table. And here's a review of what they look like. So let's talk about what we should expect to find. Remember, our full outer join returns matched and unmatched rows. And we've done some queries already, so we kind of know now the relationships that exist in our database. So when we did our inner join, we know that there are 5 courses where there's a match. So we can at least expect to find 5 results in our full outer join. That means there's 5 courses that do not have teachers assigned. These are the unmatched results. So now our running total is up to 10. 5 from before, from the matched and 5 from the unmatched. And also, earlier when we were doing our queries, we know that there are 3 teachers that are not assigned to courses. So here's 3 more unmatched ones that don't have courses. So now we can add another 3 to our results, and we should expect to find 13 records if we do our full outer join. So let's do our full outer join, and this time to make sure we understand why it worked, instead of displaying records, we're going to count and make sure that we had 13. So our select statement is going to use the count like we have here. And if we run our full outer query, just like before, we're joining our courses with a full outer join to our teachers. And our relationship is on the teacher IDs. And we get 13 results back. Now, the reason we want to talk about a union is although an outer join is a legitimate SQL query, it's not supported by MySQL or PostgreSQL or MariaDB. But all's not lost because we can use a union. An outer join, and I mean a normal outer join, is simply the results of a left join combined with a right join. So to do that, without the ability to use a normal outer join, we can use a union, which does the same thing. We're going to use a union between a left join and a right join. The only requirements are that the number of fields in each select statement has to be the same number, and that the data type in each of those fields are the same. So let's take a look. If we look down here, here's our union. We're going to select all the names from the school table. We're going to do a union with the select query, and we want to see the names from all the teachers. So when we looked at our tables before, we know that there are 6 schools and 7 teachers. So when we run our union query, we should expect 13 results, or 13 names. 6 of them will be schools, and 7 of them will be teachers. And there we go. We got our expected results. We ran our union query. We're doing a select name from schools, and we're also doing a select name from teachers. And we have our union. So let's put all this together that we've talked about and query all of our tables at once. This makes perfect sense, especially for a school district. It would be very common if we wanted to run a report on a particular school. We might want to know what teachers teach at this school and what courses are taught at this school. So this is a perfect illustration of establishing multiple relationships on multiple tables. So this is the query that we're going to run, and let's break it down so it makes more sense. Because you've seen this all before, it's just now it's all mushed together. So let's start with the beginning. What information are we interested in? So we want to see the name of the school, and we're going to, since we're dealing with multiple tables, we want to explicitly say we want the name from the school table. We want the name of the course from the courses table. And lastly, we want the teacher's name from the teacher's table. We're using the as to make the results a little more human readable. Schools.name isn't as attractive as if we just use the word school. So that's the purpose of as. You'll see that in the results shortly. Let's continue on with our query. Now we're establishing our first relationship, which you've already seen before. This time we're establishing our relationship between the schools table and the courses table. And our relationship is going to be based on the school ID from each of those. And here we establish our second relationship. We can do another inner join. And this time we are joining our teacher's table. And the relationship will be the teacher ID on the teacher's table and then the courses table from earlier. And lastly, we're only interested in running a report on the school district or the school building whose school ID is number 6. So if we put all those together and run our query like we've done here, we get our results. So it looks like there are 2 courses being taught in the school whose school ID is number 6, which is School F. English and sociology are being taught there, and now we know that Patricia and Earthly are the teachers of these. Let's do the same query again, but this time let's put all the primary keys again in our results as well. I think that makes it more easier to understand, to see the big picture. So that we know in our query, we're only interested in the school where the school ID is number 6. So that's how we found School F. Here's our school ID in this column, and it's number 6, so now we know that it is School F. We also know when we looked at our courses table earlier that the courses have the school ID. So on our first relationship, we can match the courses to the school. English and sociology both had a school ID of number 6 in there. So that's how we got that relationship. You also might remember from earlier that the courses table had a teacher ID. And that's how we get the relationship with how we know what teacher is in there. The English course had a teacher ID of 1, which is Patricia. The sociology class had a teacher ID of 7, which is Earthly Earl. So that's a good overview of the 4 different types of queries: right, left, inner, outer. And we also talked about unions and then how to combine all this into multiple queries. That's the end of our presentation. Thank you for listening. I hope that you were able to take something away from all this.